I want you to understand how Camino Network is special, what features are there, and how you can best leverage it. So you now know what solutions you need to be looking into. And we are getting to the code. So for our first example, we will be using an online IDE called Remix, and for the latter ones, we'll be using Hardhead. And the reason for that is that Remix offers us a local environment which you can view as a sandbox. Some play accounts, which you can find here, with some play funds. So I need to mention now. So you see here Ether, but all you need to know for now that Ether is an equivalent of Cam on Camino Network. So let's look at the code structure. Smart contracts are written in Solidity. Solidity is a statically typed, object-oriented programming language. And it is somewhat similar to C++ and C#. The structure of the file goes like license in the top, then compiler version, import if we have one, object of a contract at the core of it, state variables at the top, and functions at the bottom. For the first example, we'll look at the most minimalistic implementation of any smart contract. It will be able to store some value, and we'll be able to retrieve it. So let's look at the syntaxes. So in here you see a state variable at the top, and the syntaxes goes like data type, visibility specifier, and name of the variable, and a value if we decide to assign one. If we don't assign the value, it is going to be set to a default one, and for integers it is 0. So what is this one? What is private? Private is the visibility specifier. And there are 4 types of visibility specifiers in Solidity. It's public, internal, private, and external. And public, internal, and private apply to both state variables and functions, and external is exclusive to functions. Visibility specifiers are just a way of saying from where our variables or functions can be accessed from. So if we are saying public, you can call or retrieve a variable or a function from anywhere. Internal, you can only access it from within the contract and from the contract inheriting our contract. Private allows us to only access it from within the contract and not inheritances. And external only allows us to call it from the outside. Now, any transaction or interaction with a smart contract has some properties, and one of them is address. So contracts can be called by externally owned account, which we have some of here. They are all play accounts with play money. And contracts can also be called by another contract, which means that contracts also have addresses, and that is how we address them. So let's try to go through the process of deployment and see how we actually do it. So we need to first compile this file, then go to the deployment page, choose an account the call is going to be initiated from. Let's choose the last one, and we click deploy. We see that it was a success, and we now can find our contract at the bottom. If we roll it out, we can see 2 buttons. One says get number and the other one is set number. So this function inputs or stores the value on chain in the smart contract, and get number allows us to retrieve it. So any interaction that stores some data or changes some data of the smart contract is changing the state of the network, which is why it is also taking the capacity of the block and thus costs money or gas. But if we are viewing a variable, we can do it for free. So let's go ahead and check what number we have at first, and it's 0 because that's a default value for integer. And let's try to put 42 now. The transaction goes through. We check again, and we see that indeed 42 is now on chain. So let's try it again, but from some other account. And you can also see that prior to the call we had 100 and now we had 99.9 something. That is because the action of calling the contract, which stored the number, cost us some money. And if we try the other account and click get number, we see that we get this number, but the funds are still here. So now let's make this account store some number, which is going to be 84. And afterwards, we can see this 84. And that is everything this contract can bring to us. So we are moving to the next one. The next one is going to be quite a level up, because now we don't have a unitary smart contract, but an ecosystem of them. And what we have here is token, ticket, ticket control, and ticket booth. This ecosystem is supposed to have this ticket booth where we can buy a ticket via our token and then go to the ticket control and validate our ticket or enter the event. So let's go one by one. We will start with the token, and you see it's now a bit more complicated. And we have something new here. This is an import and an inheritance. The way inheritances work here is that by inheriting a contract, you actually adopt all the methods and variables of the contract, except for those that are set to be private. And you can see this word ERC20, and you might have already heard or seen it somewhere. So what is it? ERC stands for Ethereum Request for Comments. And it is a standard which was proposed and approved by the Ethereum community, which tries to enforce some rules of some type of interaction. And ERC20 is such implication at creating an equivalent of money. So this is a smart contract based currency on blockchain. And if we take a look at the contract of ERC20, we see it here. We won't see much because there are a lot of distractions. But if we took our time, inspected it, we would see that it is quite simple, because all the interactions or transfers of the tokens come down to deducing the balance of one user, which is sending the money, and incrementing the balance of the one who is receiving it. And in here you can also see two more functions, which are mint and burn. And these are required by this ERC20 standard to be overridden. That is done so we can implement our own custom logic. And in this case, we use it to restrict it, because you can see here that we have a line which has require message sender to be the owner, not an owner. And we do so that not everyone can call the function mint and burn, which would mean creating the token and deleting it. But we instead only allow the deployer of the contract to do it. And the place where we set it up is in the constructor. So constructor is a function which is only run once at the deployment of the contract. It is usually used by the developer to set up some things that are needed to be there. So let's move to the next one, which is a ticket. And it is somewhat similar, but now instead of 20, you see 721. And 721 is something that you know as NFT. And in reality, both NFT and tokens are implications on the dilemma I described before of having a digital equivalent of essence be present in the world of smart contracts. So to best explain how they work, we first need to know what NFT stands for. And it is non-fungible token. And now we need to compare it to ERC20 token, which is fungible. So think of ERC20 token as an equivalent of money. If you have 100 of $1 bills, each one of them is equal in price, because its value is only influenced by the denomination of this $1 bill. But if we think of our ticket, the ticket also has some additional features which are responsible for the value of our item. Like, for example, a seat. So if we have a ticket can be cheaper or more expensive depending on the seat it has. So that is why we use an ERC721 here. There is one more interesting thing here. So I went ahead and compiled and deployed all of these to save us some time. But we need to set up one thing. So it's set both. And it is done so that, unlike the previous example with token, we don't have owner be able to mint the token, but only allow a contract which is responsible for selling the ticket to be minting it. So next, logically, we come to the ticket booth. And at its core, we can see two functions, buy with cam and buy with token. And we must explain what this means. So there are different types of money present in the smart contract world. So first one is a native currency or native token. And the other one is the one we have just described, an ERC20 token. And native tokens is CAM for Camino, Ether for Ethereum network, Bitcoin, Solana, and so on. And token are all the other tokens that there can be many of on one chain. And the difference between them is that the functionality to interact with native currency is embedded, built in into the Solidity language. And in order to interact with ERC20, we interact with different contracts. So let's look closely. When we call the function to buy with a native currency, we check whether the message.value was more than the price we require it to be. Which means that when user initiates the call, it can simply attach this amount to the call of the function. And if we compare it to buy with token, we see that in here, we instead call a function on the contract of token. So we also take a look at the last one, which is ticket control, and it's pretty simple. It has this function of enter. It checks whether we haven't previously entered and checks if we have a ticket. So now it's time to tell you about this require statement. The way it works is we say keyword require, brackets, we put in a condition and a message that is going to be output in case the condition is not met. The way functions in Solidity work is if we call this function and we pass these require statements, then the code afterwards executes. But if we don't pass them, then all the changes that were executed prior to this, like all the lines before the require statement, will be reverted and the state will come back to what it was before calling the function. So now let's look at our deployed contract. As I've said, we need to make one setup here, and that is need to be done at ticket. We need to set the address of the booth, which is going to allow the ticket booth to mint tokens. So we copy the address, paste it here, and press set booth. And now we can see that we have an error and it says admin only. And the reason because we used a different account from the one that was deployed. And that is what we need because that proves that our contract works right. So now let's take the first account, which was used to deploy the contract and which is the owner, and do the same thing again. Now it was a success and the ticket booth was set. So let's go to the ticket booth and we can see these functions. So you can see that these two buttons are different colors and it is not just style, there's reason for that, because let's go back to ticket booth. This function is set to payable, and by setting a function to payable, we allow some message.value to be attached to it. So we can attach some native tokens. In fact, we need it for the function to work. And also for the contract to be able to receive these funds, we need this function at the bottom. Without it, it simply won't work. So let's look at the top now. We see here two variables, price native and price token. So we have a price which the user has paid for the ticket if he wants to buy it using a native token, and a price which he has to pay if he wants to buy it with an ERC20 token we have created. And if we now try to press buy with scam, it is going to revert. And the reason for that is, you can see not enough funds set here, because the value we attached, which is 0, wasn't more than the value we asked for. And in here you can see it's like 5 times 10 to the power of 18. The reason for such thing is that Solidity doesn't work with float numbers. They simply don't exist in Solidity language. And the solution out of this was to create this denomination. And most of the currencies have 18 decimals, meaning that 1 and 18 zeros would be equal to 1 ether, or ether or cam. So let's now attach the value, which should be more than the one we're asking, which is 5. We put 5 here and we call the function again. And now it is a success. We now have this ticket. And in order to check whether we actually have the ticket, we go to the ticket control and try to enter. Success, and we check whether our address has actually entered. And you see here it says true. So let's try to do the same thing but with the other account, which will now, we'll first check whether it has entered. Oh, oops, we have to grab it. So we check it and it says false. So if we try to enter, it is not going to work because it says you need the ticket. And that is perfect because it works. But we also need to try to buy with tokens. And in order to that, we need to go to the only account which has tokens, which is the deployer. And we first need to initiate this transfer of tokens to some account that is going to be buying. So let's choose one of these. This one looks nice. We take here and we open the function transfer. It takes 2 arguments, the address, which is going to be receiving our funds, and an amount. So if we try, we need to input at least 10 and 18 zeros. So let's go with 20 and 1, 2. Okay, once again. Yes, that should be it. And it says transfer amount exceeds balance. So we might have got 1 0 too much. Okay, that is not important. Let's just miss this point. So that is it for the ticket.